Hello everyone. I thought I'd start with a cup of tea and my old laptop just to show you my coding setup. So I haven't got any fancy equipment, no Apple products or anything. This is a 5-year-old Dell. It's running Linux Mint and I use NeoVim and that's it really. So what we're going to look at today is the state pattern. So state pattern in Rust. Let's begin. Okay, so the example I'm going to type out is what I've actually memorized from this book, Rust Crash Course. If you go and search for it, you'll find that it is available via BPB, I believe. BPB. So that's the book. I've also done a few examples and put them on my website, redandgreen.co.uk. This quote is from the Rust documentation. The state pattern is a behavioral design pattern that allows an object to alter its behavior when its internal state changes. In Rust, like in other programming languages, you can implement the state pattern to encapsulate different states of an object, manage transitions between those states. The first thing to really pick out is the fact that we need to be using a trait as a type. What does that mean? Right, let's begin the code because I think probably the best thing to do is type the code, and if I happen to make any mistakes, then it will most likely be on the more difficult parts, which hopefully will be the same parts that you would also have issues with if you're at a similar level to me. So I've been learning Rust for approximately a year on and off. So yeah, state pat YT. And let's open up the main.rs. Okay. So with the state pattern, you have, it works because of the trait. The trait which is called state. And I think the best thing to do, especially because then you can pause the video and you can then sort of, you can see the development of the project. So struct start, struct running, struct stop. So the thing that we're going to be dealing with is going to have 3 states. There'll be a struct for each state because you need a struct to then be able to give you the implementation, which will then run the trait, or call the trait. Apologies if I say any of the technical stuff incorrectly. I'm making it a priority to learn the code over the exact terminology. I hope that's okay. So we'll put an impl below each one of these structs in just a second. So then we need to create a struct to store the state. So that's going to be state context. And then within main, what we'll actually be doing is we will be, let's just put some comments, create a context. So context basically is, not sure what the exact definition of context is, but we'll see when we've done the code. So right, impl. Let's do an impl for impl. So we're going to implement the state trait for start. And that's not complaining because there's actually nothing in the trait yet. So again, I'm trying to build this up in such a way that you can pause it and you can kind of see the structure of it. Because I think sometimes rather than just proceeding down through the code sort of sequentially, it's good to see the framework, or not the framework, but the structure, the the boilerplate for it. For state. So these three are pretty much the same, but obviously just different states. We've got start, running, and stop, and they've each now got an implementation, albeit a blank one. Okay, so 3 states, and each of those states will implement the trait, which we're about to write. And within this struct context, we will, we'll also have we'll have an implementation of the state context as well. And within that implementation, we will then have we'll have a function for new to basically be a constructor. We'll have a function called set state, and we'll also have one that calls process, but it'll actually be calling process on the state which we've yet to write. This last bit, I'll point something out when we get to it, because potentially if you are running process, you could get a buffer overflow. I'll show you what stack overflow. I'll show you what I mean in due course. So let's write the function for the trait, which is going to be called process. And it's going to take self as an argument. So then we need to do fn process, and we need to just make it do something like print. So it's going to print started. We'll do the same here, fn. So for start, running, and stop, we're going to implement the same trait, or we're going to use the same function, which is part of the trait. So let's do running, and finally we'll do this. We'll do the same for stop. Okay, good. Right. So now we've got a trait called state, which has a function called process, and then we implement that trait for start, running, and stop. And we want to add something to the state context. So this is where it gets interesting, and this is what really confused me a lot when I first started trying to learn it. So the state context has a variable called state, which is fair enough. But this is where it gets really, if you're coming from a beginner, this is the first time you see it, it's kind of a bit unusual, should we say. Normally you would have a primitive, so you'd have i32, or you'd have a string, or maybe even you'd have a vector or whatever. But here we're actually going to be having box dine. Then we have the name of our trait. Very important, this. It's the name of the trait, not a function, not a primitive, not a struct name. This is the name of the trait. So the trait is called state with capital S. As I say, I'm doing this from memory now, honestly. But if you want to refer to the source of where I got this from, then it's in this book. You can also do it on ChatGPT, and also I've done the quite. You can commonly come across a a traffic light example, which, yeah, I've got it here. This traffic light example doesn't use box down. It doesn't. So possibly easier, but really the whole point of this is trying to learn the one that I've seen in this book, which I think is a good thing to learn because it introduces you to dynamic dispatch. Right, so we've got a state context. Now let's do the new function, and that's not going to take anything, and it's going to return self with a capital S because it's that means it will be returning a type of state context. Okay, so we want to return a state context, and in here we need to return state context and the state column, and then we want to return box, the new box, and inside that we want to return the state, which the state at the start will be start. So let's put in start with the and yeah, it's accepted it. So I think I've remembered that correctly. Okay. This is like walking a tightrope. I've only learned this week, so right. We want to pass in here. We want to pass in a mutable reference. So ampersand mut self, and then this is the bit that is a bit unusual. So we want to be passing in box. In actual fact, it's box, and then it's the same as what we've got up on line. What's shown as line 8. So dyn state. And it's not returning anything as such because it's modifying. So here we're just going to say self.state equals s, because s is the box that we pass in. So we're going to pass in a box which will contain the state. So it's basically state in a box. We're going to pass that in, and then we're going to make the current state will be equal to whatever the state of what we pass in. Okay, and then we're going to have process, which is going to process it. And there we're going to pass in reference to self. So that's going to match process there. So here we will be saying self dot state dot process, and it's not returning anything because it's working on the instance of the structs, so it's modifying it in place, as it were. Okay, let's try it out. So we're going to create a context. So it needs to be mutable. So let mutable context equal, and then we want to run our new function. So state context double colon new, and that's it. So here, this line is actually should just be doing this. So it should compile. Let me just get rid of the hashbang allow. I don't know if this is the best way to write it, like hashbang allow unused, but it's a habit that I've kind of got into. Okay, so that compiles. So we've created a context, and it's a new context, so it will be start. So we need to then modify the state. So we need to do ctx dot set state. You see it's there in our list of available options. No, this is the bit that I got wrong a couple of times. We need to be passing in a box. We need to pass in a new box, and then we need to be passing in the running struct because we want to update the state from started to running. So we've set the state, but we need to actually process it. The process will actually, by doing process, that will then run whichever one of these three it is relevant to. So fingers crossed, it should do this. So it should print running. ctx dot process. If we run this, we should see running, which we do. Good. So if I copy these two lines to yy, e, and now if I change that word running to what's the struct? Stop. So now it should print out running, then it will set the state to stop, and then it should print out stopping. There we go. So this has hopefully introduced you at least to the possibility of passing in a trait as a type. So with your variable binding, you can have a trait, and then the trait dynamically chooses that runtime, which function to run. Refer to the documentation because my explanations may not be accurate here, but the code works and I've remembered it correctly, and I wanted to make this video to basically check that I could remember it correctly, and also if I made any errors, chances are they would be the errors which hopefully most people would encounter, or that struggle with the things that others would struggle with typically. So there we go. That is state pattern. Admittedly, a basic example taken from a textbook or memorized from a textbook. As you saw, I've not been cheating. I haven't got two screens or anything. But there we go. So if you want to play around with that, you could also add more lines. But each time you add something, you just need to process it again. So I change that back to start. And just process it. Running, stopping, started. And if you're not familiar with the state, then also have a look at finite state machines. I did a recent video on it, probably not my best ever video, but at least it kind of covered it, or hopefully just piqued some viewers' interest into what a finite state machine is. There's a lot of theory behind finite state machines, and you can draw the diagrams, and you can also do a table, which is beyond what I'm going to do here. But yeah, there we go. That's how to implement a state pattern in Rust. So credit to this book because I'm thinking I've probably memorized it word for word. I won't know, but um, state, trait state, and remember to add the state context. So you have a trait which can run on either of the three states. State is defined in the struct called state context, and then the logic is in the implementation of state context. Then you've got new, set state, and process. And on that bombshell, I'll leave you. Thank you. Thanks for watching.